Hi, it's my pleasure to be here. My name is Yuezhou, a PhD student supervised by Professor Richard Dobson and Dr. Florian from King's College London. Today, I will talk about the relationships between depression and circadian rhythm in mobile health. I will first talk about the background of depression and explain why it is necessary to investigate the utility of mobile technologies for monitoring depression. And then I will introduce the findings in our previous research about the relationships between depression symptoms severity and individuals' behaviors measured by smartphones and wearable devices. The circadian rhythms and their relationships with depression were also assessed by different data streams, such as Bluetooth, GPS, and sleep recordings. Finally, I will discuss about our future work and challenges. Depression is a common and serious mental health disorder. It can cause several adverse outcomes, such as physical health and psychological function problems, resulting in loss of productive and high social burden, and it is a leading cause of disability worldwide. However, currently, depression diagnosis relies on scaled clinicians and self-report questionnaires, which have limitations including subjective recall bias and dynamic information loss. Consequently, many people with depression do not receive timely and effectively treatment. Therefore, more efficient methods for detecting and monitoring depression are needed. Previous survey-based studies found that depression is closely associated with individuals' daily behaviors, such as sleep, social interactions, and network, mobilities, gait patterns, and circadian rhythms, etc. These behaviors all could be captured by mobile technologies, such as smartphones and wrist-worn devices. Therefore, several studies started to investigate the use of mobile devices with embedded sensors for monitoring depression. It provides an unobstructive, continuous, and cost-efficient means for supporting both patients and clinicians. One challenge is how to collect multimodality signals simultaneously and effectively for a long term. Our mobile health group developed an open source platform called Radarbase for this purpose. It can collect passive data such as steps, heart rate, and temperature, etc. from wearable devices, and smartphones data such as Bluetooth and GPS data. It also can conduct active questionnaires through study apps from a regular frequency based on specific disease of interest. All passive and active data streams could be uploaded and stored at a FTP server for real-time visualizations and analysis, and secondary use for developing some algorithms. An EU longitudinal digital depression study called RADAR Major Depression Disorder used the platform to investigate the use of remote measurement technologies to monitor people with depression for up to 2 years follow-up. This study recruited 623 participants with depression history from three study sites in UK, Spain, and the Netherlands. Participant depression symptom severity was assessed by the PHQ-8 questionnaires through smartphone every 14 days. And participants' phone data like Bluetooth, GPS, and Fitbit data such as sleep, step, and heart rate were collected continuously over their follow-up time. I also list the papers of a study protocol and the description of the study if you are interested. Before I summarize our previous findings in this dataset, I want to highlight the relationship between circadian rhythms and depression for today's topic. Circadian rhythms, also called circadian cycle or 24-hour rhythm, is driven by a circadian clock in human body. Depression may lead to misalignment of the circadian rhythm and make people's life rhythm, such as sleep rhythms and social rhythms, more irregular. We tested whether circadian rhythms and their associations with depression could be captured by mobile technologies in our previous studies. First, I want to talk about the depression and Bluetooth data. Since depression closely associated with individuals' social levels and status, such as the social interactions and work status and loneliness, and these behaviors and status can be reflected in the nearby Bluetooth device count data. We explored the Bluetooth data and their associations with depression. Here is an example of Bluetooth data in daily activities. The Bluetooth data can reflect changes in behaviors of many scenarios in real-world settings. And these two figures are two 14 days Bluetooth sequence from the same participant of two different time. And because PHQ-8 questionnaire reflect the depression status for the past 14 days. So we use the 14 days as a window. The PHQ-8 score of left figure is less than 10 points, that we can consider the participant at the time of left figure had no obvious depression symptoms. On the other hand, the right figure shows the significant depression symptoms as the PHQ-8 score is greater than 10. This participant had lower amount and variance of Bluetooth data when he or she in a depressive status. We extracted several Bluetooth features to describe the amount, variance, complexity, regularity, and periodicity, especially the circadian rhythm for 14 days sequence. And I will explain the frequency domain features related to the periodicity and circadian rhythms. We performed the fast Fourier transformation with 24 hours as the sample rate to transfer the Bluetooth sequence from time domain to frequency domain. The power around 1 circles per day could represent the proportion of circadian rhythms in 14 days. Then we manually define 3 frequency intervals and use the middle frequency interval to reflect the circadian rhythm. The result of this study can be summarized as when the depression symptoms worsen, one or more following changes were seen in the preceding 14 days Bluetooth sequence. There, the amount and the variance decreased, and the periodicity, especially the circadian rhythm, decreased, and Bluetooth sequence may become more irregular. Next, I will talk about our findings in GPS data. Depressed people have lower mobility than not depressed people. was found in a number of previous studies, and a bidirectional relationship between depression and mobility was also reported. It indicated that the changes in mobility are associated with the subsequent changes in depression, and vice versa. In this study, we want to test whether this relationship over time could be captured by mobile technologies. We extracted several GPS features to represent mobility, and we also proposed 3 frequency domain features to reflect periodicity and circadian rhythm in this paper. And here is a figure to show how we transform the GPS data to the frequency domain. And we use the 3 frequency intervals to represent different lengths of period patterns. Similar to Bluetooth study, we used the power around 1 circles per day to represent the circadian rhythms. And the model used in this paper is dynamic structure equation model to find the longitude association over time. The result of this study could be summarized as for the correlation relationship, the GPS-driven mobility was negatively correlated with depression. And for the circadian rhythm, more circadian rhythms measured by GPS, lower depression score. And these findings are consistent with previous paper. And for the relationships over time, we found that features of homestay, location entropy, and residential location count significantly affect the subsequent PHQ-8 score. So that means they have the potential to be predictor of depression. And on the other hand, the PHQ-8 score have a significant and negative impact on the circadian rhythms of subsequent 14 days. That indicate that the impact of depression on the rhythms of life can last for a long term. And then I will briefly discuss our findings in sleep recordings that related to depression and circadian rhythms. Sleep disturbances are prevalent among people with depression. It is necessary to assess a sleep quality continuously. However, 2 traditional sleep assessments have some limitations. The golden standard PHG assessment is uncomfortable, expensive, and time-consuming, and not suitable for long-term monitoring. And sleep diaries rely on subjective recall and may inaccurate. Therefore, wearable devices provide a low-cost and convenient means to continuously monitor sleep in home settings. We extracted several sleep features for 14 days sleep recordings in the following 5 categories. And they are sleep architecture, sleep stability, and sleep quality, insomnia, and hypersomnia. To be honest, when we designed the features of stability, we did not consider about the circadian rhythm, but the standard deviation can reflect the variance of sleep duration and sleep start time and wake up time. So they can reflect the regularity of sleep time during a period, says 14 days. If people have a high variance in the sleep time during that period, it indicates that the circadian rhythm was disrupted. And here is an example of a potential depression relapse in the dataset. And the first row is the standard deviation of sleep duration in 14 days, and that can reflect the circadian rhythm, and it is positively correlated with depression score. So the higher variance and the higher depression score. And our result also showed that if the circadian rhythm is more regular and the PHQ-8 score of depression is lower. And findings in these studies demonstrate the use of mobile technologies in depression monitoring and circadian rhythms, and its associations with depression could be captured by smartphones and wearable devices. We will attempt to combine different features to perform the multimodality analysis and use some machine learning or deep learning methods to predict depression in future research. And the missingness of mobile health data and the individual difference and some potential confounders challenges need to be overcome. And that's all for today's topic. Thank you for listening. If you are also interested in this area, welcome to further discussion and suggestions. And thank you.